Good morning, students. In today's lecture, we will talk about chemical reaction of ethanol. Ethanol, the second member of alcohol series, and this alcohol can be consumed. It is having molecular formula C2H5OH. As it is an alcohol, so definitely the group will be OH group. So all organic compounds in which OH group is present as a functional group are called alcohol. And ethanol is the second member of alcohol. Now, about its reactions. So in your syllabus, you have only two chemical reactions of ethanol. Number one, reaction with active metals like sodium or potassium. Remember one thing, active metals like sodium or potassium have property to displace active hydrogen or acidic hydrogen from the compound. Like if HCl is made to react with Na, HCl is made to react with Na. HCl is an acidic compound because it can form H plus ion. So here this hydrogen is called acidic hydrogen because it can be released in the form of H plus ion. All reactive metals have the property to displace active hydrogen or acidic hydrogen in the form of H2 gas. So what will happen? Na being more electropositive than hydrogen, Na being more reactive than hydrogen, will displace hydrogen from here in the form of H2 gas, as a result of which NaCl is obtained. The reaction is not balanced. Here we are not talking about balancing the chemical reaction. Here we are simply talking about what will happen when sodium is made to react with acid. So it is the property. Reactive metals or active metals displaces hydrogen from acidic solution in the form of H2 gas. Or if active hydrogen atom is present, active H atoms can also be displaced by active metals like sodium and potassium. Now, what do we mean by active hydrogen? Active hydrogen are those hydrogen atoms which are attached with electronegative elements like fluorine, oxygen or nitrogen. So if we talk about ethanol, that is C2H5OH. This hydrogen is attached with the oxygen atom. So this hydrogen is active hydrogen. When alcohol made to react with active metal like sodium, then sodium will displace active hydrogen from ethanol in the form of H2 gas. So here H2 gas will be produced, and Na will form a new bond with oxygen, as oxygen is electronegative in nature and sodium is electropositive in nature. So bond formed between O and Na will be ionic in nature. So by reaction, ethanol will be converted to sodium ethoxide with the release of H2 gas. So if sodium metal is placed in alcohol, then you will see formation of bubbles in the vessel, in the beaker. And these bubbles are due to formation of H2, which is coming up and released in the atmosphere. So by this reaction, H2 gas can be produced. Now the second reaction is dehydration reaction. Now what do we mean by dehydration reaction? De stands for removal and hydration stands for water. So all chemical reactions in which water molecule is removed are called dehydration reaction. And to carry out dehydration reaction, we will be requiring dehydrating agent. And here, as a dehydrating agent, we will use concentrated sulfuric acid. Concentrated sulfuric acid can be used as a dehydrating agent. If removal of water is possible from an organic compound, then by using concentrated H2SO4, water molecule can be removed. And the reaction that takes place is called dehydration reaction. So here, ethanol, just write the open structural formula of ethanol where we have represented all the bonds. Because we want to show the removal of water, how water molecule will be removed from alcohol. So ethanol, when heated with concentrated H2SO4 at a temperature of 443 Kelvin, water molecule will be removed. And how this removal will take place? OH from this carbon and H from this carbon will be removed in the form of H2O. So H with OH will form H2O. Now, when one H is removed from this carbon, it creates a bond efficiency of 1 over this carbon. When OH is removed from this carbon, it creates a bond efficiency of 1 over this carbon. Both carbon atoms are one bond efficient. So what will happen? There will be formation of double bond between the carbon-carbon atom, as a result of which ethanol will be converted to ethene. So whenever alcohols are used with concentrated H2SO4 at a temperature of 443 Kelvin, then alcohol gets converted to alkene. So these are the two important chemical reactions exhibited by ethanol. In next lecture, we will talk about some important chemical reactions of ethanoic acid. That's all for today. Thank you and have a good day.